So in the next session, we'll have two speakers, Mr. Cheung, Partner Business Evangelist of Microsoft Hong Kong, and Mr. Davide Benvegnu, Director and CTO of DBTek. They will share with us DevOps at Scale, a true story. So first, let's invite Mr. Cheung, please.
So, hello everyone. Let's wait for the slide to come up. Yes, great. So, hello everyone. My name is Andy and I'm from Microsoft. So, Microsoft has been participating in WIDS for many years. And I know that this year we have a theme which is around DevOps. So this year we think that, hey, how about we come up and do some of the sharing of how Microsoft is doing DevOps ourselves. So in these sessions, I will spend around like 15 minutes to share with you some of the internal changes that Microsoft have made in our own development teams, okay? We're changing the ways how we develop our own software for all the consumers, for the enterprises. And this is actually quite a change. So I've spent like the first 15 minutes on this. And then I hope this will set a good stage for our next speaker, which is David. David is our Microsoft MVP, the most valuable professional, and he's also very experienced in DevOps and also application lifecycle development. And he will go on to share with us how development teams of different kind of projects, no matter open source, no matter you're working on iPhone, Android applications, cloud, etc. How can these development teams leverage Visual Studio Team services to implement DevOps in their projects? So now let's take a look at how Microsoft is doing ourselves. Now, first of all, I'd like to give you some numbers. How many developers does Microsoft have? So this is actually some numbers that in Microsoft, how many developers inside Microsoft are actually using Visual Studio Team services today. So Visual Studio Team services is actually our system, our solution of implementing DevOps. So David will have a more deep dive session on what this is. But when we are looking at this, you can see that we have a growing trend in the past couple of years. More and more developers within Microsoft are actually doing this. And right now there are around 43,000 developers in Microsoft, which is scattering across the globe. Some of them are in Redmond, in our headquarters, some of them in India, some of them in China, in different parts of the world. So this is actually the number. So we have really a big group of developers working on different kind of Microsoft products. Now, when you think about how Microsoft is building our own applications, how we're delivering our applications, there are actually quite some changes in the past few years. Now, think about Office. I think every one of us have been using Office, right? So right now on your phone, no matter you're using iPhone, Android phones, Windows phones, you will be able to download Office in your device, right? Now, think about how we deliver Office in just a few years ago, okay? Now, we are actually delivering our software in a longer life cycle, okay? When we think about when we have like Office 2007, and then what is the next version of Office that was like in Office 2010, right? So that is a 3 years gap in between. However, in today's world, we are already making a lot of changes in delivering our software. Now, if you subscribe Office 365, it is actually, we're actually delivering this kind of changes in a much shorter way because we change our business model from selling box set software like Office 2007, like Office 2010, into a subscription-based model, which on Office 365, you pay per head count per month, right? So this is actually a big changes. As long as you are subscribing Office 365, you will always get the latest version of Office, right? So this is actually a big change from selling box set software to cloud. Now, how does Microsoft development teams make the changes to cater of these kind of changes? Now, if you look at another example, Microsoft Azure. just in the past 12 months, there are over 500 new features added to Microsoft Azure. That is over, around 2 new features per day. Now, if we are developing this kind of updates, this kind of new features so frequently, the old model of application development actually cannot meet this timeline. It cannot meet our goal of delivering values to our customers in a shorter time. Now, let's take a look at how we did it in the old way. Now, this is actually the old way. On the gray part, we're actually, our development teams will be doing some of the plannings. And then on the deep blue part, we will do some real coding, right? Some real coding. And then we will test our code and stabilize our code. We will find bugs, we need to fix those bugs and then stabilize the code. And then after that, we will release a beta version of our software, right? And then after the beta versions, we may get some user feedback, etc. We do some more of the coding, and then we further test and stabilize the software, and then we go to RTM, okay, release to manufacturer, okay, or release to web, RTW, okay. So and that is actually the release of our software. Now, what is the problem of this is that, hey, during the beta stage, for example, we may be receiving a lot of user feedbacks, and we may say that, oh, this is actually a good feature to add. However, when we are receiving this kind of feedbacks, we won't be able to respond to it in a fast way, because the future, like 2 months or 3 months, we are already booked for building some other new features, right? So in this way of working, it is very difficult for us to deliver new features in a very short time. So what we have tried is that, how about we shorten, we do some kind of short sprints, a few rounds together, and then do the stabilization of code all together. Now, this also have some kind of problems, and that is, for example, if team A, they are doing, because they know that when we're doing the sprints, there will be a stabilization period. So they will be, some of the teams may choose to build, for each sprint, they will debug, they will do the stabilization of the code during each sprint. That is actually good. But for some other teams, they may think that, hey, I've got a full stabilization period, which is like for a few weeks. How about they're actually tempted to do so, and they will be tempted to deliver more features during those sprints, and then leave behind the bugs, we'll fix them later during the stabilization period. So that will actually leave two teams in a very different stage when we all come to stabilization period and we need to do those kind of integrations. So this also have its own problem. Now, what we have changed right now is that we want each of the small teams to take ownership of the code that they have written. During each sprint of like 3-week sprints, we will repeatedly have that 3-week sprints for over the full period of time, for over the 2 years. Now, during each of these 3 weeks, what will happen is that first, at the beginning of a sprint, they will be doing a sprint planning, okay? Each of the small team will be defining what we want to accomplish at this sprint, which is a 3-week time frame. And then after 3 weeks, they will also summarize of what they have accomplished. And then record some demo videos, short demo videos to let other teammates know. So this is not just for the teammates or the group, maybe 10 developers that they are working together, but it is for the whole team that's a development team that are working on the same product. So there may be hundreds of developers working on a product, and then every one of them will be able to get this kind of sprint accomplishments emails or summaries for all the other teams. So everyone will be able to sync up and know what other teams are doing, okay? So, and then after each sprint, they will be deploying those codes to the actual production. Now, these are some of the real emails that taken from our internal development teams. You can see that at each sprint at the beginning, we will have some planning emails. That's the one on the left. And you can see that that's the plan. We list out what exact features that we want to accomplish during this three-week period. And then after that, we will have a summary email together with some of the videos demoing these features so that everyone will know, hey, what their neighborhood team are doing. So usually they will be keeping this kind of videos, a short one, for example, 2 to 3 minutes, so that it's easier for the other team members to really look at all these videos and get a good understanding of what the other teams are doing. So this is actually very different because in the past, even we have a repository of source code, we have a tracker of all the work items. It's difficult to get this kind of a summary or get a sense of what other teams are doing. What is worse is that, hey, if I have if the whole development period is like 2 years, 3 years time, the code that I have written today is actually there's a chance that it won't be shipped to the real users in the next 2 years. So that is really bad because when we really ship this kind of code to our end users and then they have feedback on it, when this is routing back to the developer, is already like 2 years ago. He may not be able to get all those informations or remember why or how he built this kind of features or this kind of code. So by keeping each sprint a short sprint, we'll be able to deliver value to our end users in a much shorter time. And then we'll be able to get feedback. And more importantly, each small team will be able to take control and the ownership of that also, because when they will be able to ship it in a shorter time, they will be able to get feedback in a much shorter time. And then if there are bugs, if there are things that doesn't work, they need to take the ownership and fix them themselves, okay? And so this is actually the way that we have changed in the past few years. So in terms of these 3-week sprints, each of these 3-week sprints will have a week 1 beginnings to do the planning, and then week 3 we are done, and then we have like a 1 week to check if everything is working, and then we'll deploy those new features. So that is why you will be able to see like 500 new features on Microsoft Azure in the past 12 months, because each of them are built by small teams, each of them own themselves, and then they will be able to share their accomplishments across the whole team that are working on this product, okay? So for a quick summary, what we have changed is that the old way, we write the code, and then we hand the code to the end customer after like 2 years. But right now, when we have implemented DevOps, we have changed our way of development. We're actually have a much shorter cycle, and the user will be able to give us feedback right away, and then we can make adjustment in our product. So now let us pass the stage to David, and he'll share more about how the actual implementation of Visual Studio team system will work. Okay, let's welcome David. Thank you.
Good morning, everyone. Okay. Sorry. Do I need to change the resolution of the? Is it better? Still. Sorry for this. Which resolution is the projector? Maybe, yeah. Sorry. Maybe the recommend one would be okay. Let's try first. But who's the cost change a lot? Ah, wait a second, sorry. 佢個 projector 咧，嗰個色係幾多啊？120。Oh, because it's changed to the specific computer, so we need to be changes. So, yeah.
This one is actually good.
Yeah. Yeah. Okay. Okay.
Oh yeah, this.
Sorry. Well, let me briefly introduce myself. I'm Davide, and I'm the director and CTO of DBTek Limited. And previously, I was the international development manager for the Aruba.it. That is the biggest service provider in Italy and one of the biggest of Europe. And later you will find why I'm saying this. I'm also a Microsoft MVP, as Andy said, most valuable professional. That is a title that Microsoft gives us as third-party professionals to recognize our expertise in particular fields. In my case, in Visual Studio application lifecycle management. I'm also a speaker, I'm a trainer, and I'm a community contributor, and I have more than 13 years of experience in IT and software development, and more than 10 years of experience in application lifecycle management and DevOps. And it seems that today I will not deliver my presentation. Okay. So today we'll talk about DevOps, and we will talk about some tools. But remember that when we talk about DevOps, the two most important parts are people and processes. And Andy talked about that before, because when he spoke about how Microsoft do now all the development, he was talking about how they changed their mind, talking about people, and how they changed their processes in delivering and developing the software. So these are the two most important parts, and the tools just came to support you in those changes. And please don't think that the adoption of the tool is the goal of the DevOps transition. The tools are there just to help you adopting the DevOps methodologies and techniques. Also, when we talk about DevOps, we will probably talk about DevOps framework and all the things that are involved in DevOps transformation. And they are, okay, you cannot read there, but they are source and version control. You will have some test tool set. You will have some continuous integration and continuous deployment scenarios. Of course, you will deploy that to different environments. And most important is the part of the right. You will need to monitor all your things, software, environment, platforms. and learn from that data you get, because you can integrate that feedbacks both from tools and from users in your development cycle to be able to have better quality and better performances of your software. And all of these things are put together by your processes that you can use your existing processes. You maybe have to change some of existing processes, and you maybe have to implement new processes to have what, for example, Andy said before. So how usually the developers nowadays works? They have their machines. They probably have a source code repository and version control. They push the code in there. Then they generate a build in some way, and or even worse, they don't use the software source control, and just they generate a build package on their machine, and they send that in some way to the operations part that takes care of deploying the software in the environments. And as you know, this is not maybe a best practice, but a lot of companies still work like this. And as you can imagine, you can have a lot of problems using this kind of processes because you will never know what you are deploying. You never know if the build package use some components that maybe were only on the developer machine and they are not on the production server or even in the development server and so on. So to have a better adoption of the DevOps, what we should do is to at least implement some continuous integration and continuous deployment tools and processes. And it starts just with pushing your code in your source and version control, and then applying some tests on your code. And tests can be done, should be done before and after your continuous integration processes generated your builds. As soon as the builds are done and all the tests passed, you should have a continuous deployment tool to help you move your code into different environments. And maybe you can also spin up some new environments on the cloud, just taking advantage of all the technologies we have today. And using this approach, you can be 100% sure that what you have deployed in the development environment is exactly the same of what you have deployed in the integration, in staging, pre-production, and whatever environment you have. Maybe you change the configuration because different environment will have different configuration, but you are sure that they are the same bits you had in the previous environment, just with the promotion of your code into different environments. And then, of course, you can and you should implement some monitoring tools to monitor performances, to monitor heartbeat, to availability, and so on. And you can integrate that into your coding again. Putting in another way, this is what Microsoft called its Microsoft Cloud Development Platform. When you code, you will need some developers tool to generate your application code. Your application code then should be built in some way, maybe hopefully in a centralized way, and deployed to your application platform. Maybe you can take advantage also of some platform services on the application platform. And then you can have some analytics based on your actual application running to the platform, and from the platform services altogether, you can acquire those data to have feedbacks and put your feedbacks back in your coding. If we talk about Microsoft Cloud Development Platform, this translates into using Visual Studio and Xamarin, as well as Visual Studio Team Services like platform to do all the DevOps. Visual Studio Team Services, for who doesn't know, is the on-cloud software as a service version of the most famous Team Foundation server, and is the most up-to-date tool right now on the market and the most comprehensive tool right now on the market to do application lifecycle management and DevOps. And this is not something I say, but it's something all the analytics company out there say about Microsoft Visual Studio Team Services. On the other side, about application, you can leverage on two components. That is Application Insights, that is the analytics platform from Microsoft, and OkiApp that I will introduce later. And being the Microsoft Cloud Development Platform, of course, you can host your application using Microsoft Azure, like Cloud Platform, if you want. So you can take advantages of all of cloud services the platform provide to integrate into your application and to let you run it smoother or faster or with more potential for your client and for your services. Well, talking a little bit more about the DevOps solution that Microsoft brings us. This seems quite a marketing slide, but I will show you later that it's not only Microsoft, not only a marketing slide, because it says that you can use the Microsoft DevOps solution to shorten your development cycle times and deliver your value faster. You can improve quality and availability of your software and of your applications. You can optimize the resources you have and eliminate the waste in both your processes and your application. And you can, and this is also important nowadays, you can deliver mobile apps with the velocity you need using the same tool set and the same processes you use for non-mobile application. And this is quite challenging, and we'll see it later. Just a brief introduction of Visual Studio Team Services as well as TFS. They say that it is an integrated platform and for end-to-end DevOps. It means that you, in just one platform, you will have your development tools as well as your production tools, the tools you need for the production support. And this is because with this tool, you can do mostly 4 things. That is the 4 things you surely need in your application development. You can plan your work and the work of your teams, and you can track the statuses of every single activities your teams are doing. You can, of course, use it as support for development because you can host your code in there. You can do the continuous integration. You can do the test on your code in both automated way and manual way. You can then release it using the continuous deployment tool that platform provides, like the build itself and the release management tool that is able to deploy your solutions to multiple environments, even if the environment is complex, let's say a couple of clusters with some database cache and different network layers, it can be done. And again, you can test your application in automated way and giving you support for your test teams to go through your application. And last but not least, all the monitoring and learning part that you can use to acquire the data, as I said before, from your application and from the platform itself to integrate back in a circular way into your development experience. Let's say, just look on a real example. As I said before, I worked as international development manager for the biggest Italian service provider. At that time, we had 6 developers team across Europe, 1 quality assurance team, and we worked mainly on 4 products. Our cloud offering, our hosting offering, some email solutions, and virtual private server. Of course, we had also small projects, but these 4 products were the main one. And when I joined that company, they haven't any kind of DevOps support. And we decided together to go in the direction to adopt the Microsoft DevOps platform. Before doing that, we had this kind of statistics. An average project time was about 3 months. 3 months to deliver a project that can be also a small project, but usually it took 3 months. And we had a maximum of 5 simultaneous projects that we were able to run in in simultaneous way. And this is very scary because we had the rate of successful deployments to production was only about 43%. When I say successful deployment, I mean deployment that we can do to production, and then after the deploy, everything works. Was only 43%. It means that in 57% of the deployments, we needed to go to production service to do something, to change maybe some configuration, to change some code, to check if why something has had some problems and so on. And this is very scary if you think about it. We had 12 testers only dedicated to QA, and 6 deployers that was taking care of all the environments and all the deployments. After the adoption of the DevOps, the Microsoft DevOps solutions, the average project time went just to 1 month. We were able to work on 10 projects and simultaneously, maximum. And most important, the successful deployment went to 88%. That is anyway far from the perfection. We can do a lot better, but this was just in 6 months. In 6 months, we moved from 43% of successful deployment to 88%. Staying anyway with 12 testers, but allocating the testers not only to QA phase, but also during the development. And this is one of the pillars of the DevOps. You should have your tester test your application also during the development and not only in the end. And we reduced the number of needed deployers just to 2, because with the automated tools, we need just 2 of them to take care of all the things. And because the deployment in that case will just click a button and deploy to production. Don't worry, we didn't fire the other 4. How we achieved that? First of all, we moved from SVN to Team Foundation Version Control. SVN is a great tool, but TFVC gave us a lot of more power, and it was integrated in the platform. Then, after that, after we moved all the code to TFVC, we started to integrate to build our continuous integration processes. At that time, we didn't use VSTS because it wasn't really available for our needs, but now it's enterprise ready, so it's quite good. Then, of course, we implemented some tests using the automated test for the UI provided by the platform, and also the test manager provided by the platform. We started our continuous deployment with the platform itself, and use release manager to automate also the production deploy in different environments and in different servers and different scenarios. And of course, we leveraged on application insight, as I mentioned before, to analyze health and performances of our systems, both application and the servers and the platform. And all those things was put together using all the agile management tools that TFS and VSTS provide with Scrum support, Kanban support, task support, and management, and so on. Sorry, I have to go fast, but the time is running out. And so we did this for web applications. But what about if we need to do it for mobile applications? Well, we can use the same code repositories. We can use Git, we can use TFVC, whatever. We can maybe use the same build tools because VSTS allow us to build our code on also for iOS, for Mac OS X, for Android, and whatever. But what about the red parts? What about the deploy? How can you automate the deployment of mobile application? How can you automate the testing of mobile application? And what about user testing? And what about monitoring and improvement? Well, Microsoft recently acquired Xamarin. Xamarin is the platform that allows you to develop cross-platform application in C#, but not only, because they provide the Xamarin Test Cloud. That is a very powerful solution if you need to test your mobile application. Because with Xamarin Test Cloud, you can test your application with more than 2,000 real devices on the cloud. It means, and it can be integrated in your continuous integration strategy. It means that when you generate a build for your mobile application, it can be automatically deployed to the Xamarin Test Cloud and test on over 2,000 physical real devices. You can write a script of the test. You can execute it on the devices. and then get back all the feedbacks, all the videos, and if anything goes wrong, you can have also the exceptions and the videos of what happened. But not only, as I mentioned before, as side of an application inside, now we have OKApp. This is another very nice Microsoft acquisition, and it allows you to really do DevOps on mobile. This is because, for example, you can have your beta distribution platform. It means that it provides you private marketplace for your application. You can distribute your application to your testers, and you can see the beta test coverage over your application on different devices and different behaviors of your application with the tailored charts and real usage data. And of course, you can use it to have real user feedback in both beta testing. I mean, this was real people testing your application, and from your clients, your user. You can have your feedback and integrate the feedback back into your work system like VSTS. You can do it, and you should do it. And with OKApp, you can also collect all the analytics about problems your application will experience. Hopefully, no, but sometimes it happens. So you can collect all the crash data, you can collect all the exceptions, and with no additional code for iOS, Android, Windows Phone, whatever. And you can report back them again into your tool, into VSTS or TFS, to be able to work on that and to track all the things in your system. Well, that said, just a brief recap. We talked about Visual Studio Team Services, that is the cloud tool, cloud-based tool for DevOps by Microsoft. But all the things we've seen can be also used in the older, but not bad Team Foundation Server, because they are updated together. The only difference is that Team Foundation Server, you need to install it on premises, and it's updated every about 3 months, while Visual Studio Team Services follow the same thing Andy said before. So it's updated about every 3 weeks. And you don't need to install anything on your systems. These tools are open on Visual Studio Team Services. Some of the parts are already been shipped like open source on GitHub. It's flexible, very flexible, and it's extensible. You have a lot of APIs, a lot of possibility to personalize it. And you can develop and you can use it to develop and support your cross-platform applications, because again, you can compile and use your code for iOS, Android, and whatever system you are using, Java or whatever. As I said before, it's enterprise ready. They provide very strict SLA, and they respect it. And they provide very comprehensive security for the tool. You can tune almost everything. You can integrate it with your domain controller. Also, the cloud solution, you can integrate with domain controller to control almost everything. And last but not least, it enables you to do mobile DevOps because of not only the platform itself, but because of Xamarin Test Cloud and OKApp, you can do really, be effective on your mobile DevOps. Okay, this is all. Thanks for your time. We probably have some Q&A, but if you have any other question, I will be around all the day. Feel free to contact me for everything. Thank you.
So now it will be the Q&A session. If you got any questions, feel free to raise your hands and we'll hand the microphone to you.
Thank you. My name is Jack, and one question, like I saw your presentation with Andy's, and you talk about the continuous integration and all the automated testings. One of the challenges of the DevOps is like for my case is like the communication between different teams, like the mobile teams and the web service teams, and sometimes they are they have to do. Their implementation have to depend with each other. What suggestion or what kind of tools do you use to help to facilitate the communications?
Well, in our case, because I'm used to implement DevOps solution for my clients, and in my case, what I always use is for the first VSTS, because you have a very comprehensive suite of tools to also visualize the state of the work, the state of different teams. Every team can see what other teams are doing and vice versa. And then you can use or within VSTS or, for example, with other solutions Microsoft provides, but also other third-party provides, integrated communication tools. Like the internal, they call chat room, but they are most of that in VSTS, and or if you use any other kind of communication tool, like for example Yammer, like Slack, like these kind of things. There are a lot of integration between VSTS and TFS and these tools. Every time, for example, you trigger a build, you can have a notification on Slack or on other tools. Also, even by email if you want. But if you use that kind of tools, you can have also the history of what happened, and every developer and every team can go there and see exactly what happened during the time. And this is the most important part, because even if I don't know what the other team is doing, but in the end I need to integrate my code and my functionalities with what they did, I need to have an history of what going on. So I can use that tools to be aware of what is going on.
So are there any other questions?
With the experience in Microsoft and your experience,
yeah,
what would be the optimum team size you've been trying with?
Well, usually I suggest to have a team between 5 and 10 developers. This is in my experience the best dimension.
Why is it?
Sorry?
Why is it?
Why? Because if less than 5, it's very difficult for the team to take care of every aspect of the single feature. Because when we talk about DevOps, and we usually talk also about Scrum and other agile methodologies that works well with DevOps, a team, as Andy said before, is responsible for that feature. It means that they have to code, they have to test, they have to prove that what they have done is okay with the requirements. And if less than 5 people, usually it's very hard for them to do all the things. But if they are more than 10, maybe they try to implement too many things, or they try to it's not really effective in the work. Maybe the rate of the bugs is higher than a small team. So this is why I always suggest every team to be between 5 and 10, depending on how the features are done and what the project they have to work on.
Now you say it's just Andy, yeah. Well, just Andy said this morning, and there's something like a 3 weeks time frame for you guys to do these small tasks, right? Now, if you hit something that depends on the outside parties that may have different time frame, how can you manage it? Like, say, if your team develops something new, then you want to patent it, but the government is not going to give you a damn. Say 3 weeks time, we cannot do nothing.
Yeah. Okay.
What are you going to do?
Well, in that case, especially if you work with public institutions or maybe other countries, it's always quite quite hard to do it. But you have to think that about the time frame on at least what you should do internally. Because, for example, if you rely on other people, other parties, you can even still do your 3-week sprints or whatever week sprints based on some mock-up on some integration platforms. And then when the third party deliver you what they have to do, you can just use maybe one sprint more to test the actual integration and to see if everything works together. But it's always easy to say, okay, it happened a lot of time before that to say, okay, but we rely on them. We cannot respect the 3 weeks. We have tomorrow is raining, so we cannot respect 3 weeks. This is something to absolutely avoid because you need to be used on the time boxing, and you can deliver real quality software in that way. This is my opinion, of course.
So we have another question over there.
Hi, David. Quick question about the two big giants of cloud infrastructure, AWS and Microsoft. You chose Microsoft, which is cool. Did you find any specific services or tools that you would have definitely given a thumbs up for using Azure deployments or AWS?
Well, about the deployment, if you use the BSTS and TFS, they can actually deploy to AWS, for example, but because they are both from Microsoft, the integration is more smooth and effective and reliable. So this is one of the things about just the deployment. And then I personally choose Azure because I've seen that during the time I'm I think one of the most early adopters of Azure years ago, and I've seen it growing and growing and growing, and I've seen it adding a lot of more features, like Andy said before. And I know that everything is there, and it's 95% of the time work really, really well. I cannot say 100% of the time, sorry, but it works very well. And I also used AWS in the past, but my feeling about that was a little bit, okay, how can I say, it was not as good as what I had with Azure, and also in terms of reliability.
So thank you for Mr. Benvenu's sharing.